I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Hyderabad. In this session, we are going to discuss about embedded firmware design, means basics of real-time operating system. Embedded hardware is responsible for controlling the various hardware elements and generate the response according to the requirement. Suppose I am moving nearer to the door. Whenever I am moving nearer to the door needs to be open. Means here we are having some actuator. The actuator open the door. When I move away from the door, the instructions control the actuator. The actuator acts like a close the door. Like this, as per instructions defined in the embedded system, the hardware needs to be worked. This instructions is called intelligence of firmware. This intelligence embedded into the hardware at any stage of the design, either beginning stage or middle or ending stage. Once we can import the intelligence to the hardware, the instruction starts its functioning until either any hardware failure occurs or software failure occurs. At that time, if any hardware failure occurs, we can replace the corresponding hardware for proper functioning. In the same manner, if any software issues occurs, that needs to be reloaded for proper functioning of the device. This embedded hardware like a newborn baby. In the beginning stage, it doesn't know anything. What it needs to be done, that will be defined in the form of instructions. That instructions is defined by the designer. Okay. So, here we can define the instructions in the two stages. One is conventional procedure based design or super loop based firmware design. Conventional means traditional, means the task which wants to execute first, that is executed the first task. Suppose I want to do division first operation, next multiplication operation, next subtraction operation, next addition operation, like that. So the order in which I want to do the operations, in that order I am defining the instructions. The type of design is called conventional procedure based design or super loop based firmware design. Here, first I am writing main function. Next, configure the various hardware elements. Configure various parameters. Initialize various hardware elements. Okay. Configure the common parameters. Next, initialize the various hardware elements. Next, I want to do this operation infinite times. That's why I am taking while loop. Here, whatever the task I want to execute it first, that will be defined here. Task 1, task 2, and so on. Task n. Okay. So, first define the main function, configure the various parameters like variable names A, B, C, whatever the variables we are using here. Initialize various hardware. Suppose I am using LED blinking of 8051. At that time, I need to initialize the port 0. Whatever the port I am using here. Either port 0 or port 1 or port 2 or port 11. Initialize. Next, I am defining task 1. How much time that LED will be in on condition. Task 2. How much time the LED in on condition. Task 3. After the delay, how much time the task means how much the LED will be off condition. LED will be off and how much it will be on. Like that I am defining, and that will be repeated infinite number of times. In this manner, I am defining the embedded firmware in the beginning days. So what is the advantage in this method? No need to assign the priorities for each task in the sequential or particular order, that the order is fixed before embedding the firmware into the hardware. So, code length reduces. No need of defining the scheduling algorithms. No scheduling algorithms. So what is the advantage? Code length reduces. Code length reducing means execution time reduces. Execution time reducing means speed increases. Okay, that is the one of the advantages. Next, limitations. So, advantage is no scheduling algorithms. Automatically, whatever the instructions required for defining the scheduling algorithm, that instructions will be reducing here. Automatically, code length reducing means execution time reduces. Automatically, speed increases. So, limitations means if any task is waiting for any resources from any external peripherals, at that time, remaining task also needs to be wait for that one. Because here we are defining the instructions in the sequential manner. Once the task 1 is completed, then only task 2 will get the chance. That's why if any task is waiting for resources, remaining task needs to be waited. That is the first limitation. If any delay occurs, any crash occurs in any task, that affects the remaining all tasks. At that time, we can use watchdog timers. So what it will do? It will continuously monitor the process. If any task is a hangout, it will generate the reset signal. That is watchdog timer. Or we can use scheduling algorithms to come out from the hangout. Next design is, so one more limitation is, as the number of tasks increases, the task time, suppose I want to do only addition operation, the execution time is 5 milliseconds, only plus operation it takes 5 milliseconds. So for every 5 milliseconds, I will do the addition operation. Suppose I am adding one more task, subtraction operation. Suppose subtraction operation takes 3 milliseconds. So if I want to do addition, I need to wait again 3 milliseconds. Totally, for every 8 milliseconds, I am doing addition operation once. Suppose I am adding one more operation, multiplication. It takes 4 milliseconds. Let us consider. So then, if I want to do addition operation, I need to wait this 7 milliseconds. Like suppose I am adding one more operation, division operation. It takes 6 milliseconds. Let us consider. Again, if I want to do addition operation, I need to wait 13 milliseconds. So, like this, as the number of tasks increases, the waiting time to do particular operation is increases. Okay. So this is one of the limitation in case of super loop based design. To overcome these limitations, we are assigning priority to each task and do the desired operation. That type of design is called OS based design, operating system based design. Embedded operating system based design. Okay. Here, in the beginning days, we are designing general purpose operating system. General purpose operating system means here the task doesn't have the deadlines mostly, or response times are not time critical. Even some delay occurs, that is not a major problem. Okay. That type of design is called general purpose operating system. Example for general purpose operating system is Windows 7 or 8 or 10 or 11 or Unix operating system or Linux operating system. General purpose operating system. Windows 10, Linux, etc. Again, in embedded system, they have some deadlines. Within the deadline, the task must be completed. So, for that purpose, we are going for real-time operating system. Real-time means they have some deadlines. Within the deadline, the task must be completed. Example for real-time operating systems are VxWorks or iPhone operating system or Android operating systems. We will check one by one. So, real-time operating system. In what we will do here, we are assigning the priority to each task and execute the task according to the priority and make the system convenient to use. Okay. So here actual hardware is here and user applications, user apps like our Mail, Gmail app, Google browser, like various apps. So operating system acts as a bridge between actual hardware and user applications. This is RTOS. Real-time operating system acts as the bridge between actual hardware and user applications. It contains real-time kernel, real-time Kernel. Kernel is the heart of the operating system. It is directly interacting with the actual hardware. This real-time kernel provides various services. That is, we will discuss one by one. Another part is shell scripting. Shell scripting. Okay. This is called shell script. Okay. Now we are going to discuss about real-time kernel services. Real-time kernel. Real-time means they have deadlines. Within the deadline, the task needs to be completed. This real-time kernel provides various services. First one is process management. Process means some task. 1 plus 2 equal to 3. Some task. Addition operation or multiplication operation. Like that. So what it will do? First, process management deals with create the memory space for the processes. Then load the process code into the memory space. Next, assign the system resources. Next, manage and schedule the resources to the process. Next, inter-process communication. So it provides the communication between various processes. Next, process execution. Next, process termination or deletion. These all tasks will be done by the process management. It will create the process control block whenever any process is created. At that time it is create process ID. Process ID means each task contains particular ID. 1, 2, 3, 4 like that. Like our ID numbers. Process type, hard real time or soft real time. Process type. Process synchronization. Process context pointer. Process memory pointer means addresses of the corresponding memory locations. Like that. Okay. So first create the process. Assign the memory space to the process. Load the process code into the memory space. Allocate the system resources. Manage and schedule the resources. Inter-process communication. Process synchronization. Process termination or deletion. These all tasks will be performed by the process management. Second, memory management. Here memory means for storing the instructions or for storing the firmware. Here two types of memories, primary and secondary. So what it will do, this primary memory device management keep the track of which memory space is occupied by which memory space. Okay. Which process occupies which memory space. Or block 1 occupied by particular process. Block 2 is occupied by second another process. Process 2. Block 3 occupied by process 3. Like that. So, which process is occupied by which memory space? That is, keep the track of that one. Second one is, which allocate the memory space to the process based on the free memory space. Like this, memory management assign the memory space to the process, allocation and deallocation. Allocate the memory space to the process, deallocate the memory space after completion of the task. Next, I/O device management. So we are inserting keyboard, we are inserting mouse, we are inserting pen drives, we are inserting different types of sensor devices, so actuators. So based on the requests coming from various peripherals to the processing element, it provides the corresponding path to the devices. Load the device driver softwares. Whatever the peripherals we are connecting here, load the corresponding device drivers. After completion of operation, unload the corresponding device drivers. Next, interrupt services. So synchronous interrupts and asynchronous interrupts. Synchronous interrupts means the interrupt will be defined within the context of that one. That is called synchronous interrupts. So externally, the CPU may get various interrupts based on the requirement. Suppose power is down, power down means it will switch off the device. Or if system is hang out means it will generate the reset signal. Or any external peripherals wants to do the memory card read and write operations. Like that. So whenever interrupt occurs, that interrupt service routine is defined within the context means that is called synchronous interrupts. Otherwise it is called asynchronous interrupts. Next, time management. So, based on the real-time clock, it contains the real-time chip, RTC, real-time clock. So, it will calculate the how much time required for executing the particular task. So, based on the 32-bit processor or 64-bit processor or 128-bit processor or based on the clock frequency, by considering all these parameters, it will calculate the which task will take how much time. Next, so this is two types: hard real-time embedded system, hard real-time embedded system. Hard real-time embedded system means missing of deadline may cause loss of life or properties. Suppose if any vehicle comes nearer to the any object is coming in front of the vehicle, after applying the brake, if it is not working properly or if not controlling the vehicle movement, the vehicle will hit the object and object will be crashed or the vehicle may be damaged. At that time, we may lose our lives. That is, the type of embedded system is called hard real-time embedded system. Missing of deadline may cause loss of life and properties. Another one is soft real-time embedded systems. Soft real-time embedded system means missing of deadline may cause inconvenience only. Suppose ATM card. Whenever we are inserting the ATM card, if it takes some few seconds, that cause inconvenience only, not a major problem. So these are the various kernel services provided by the real-time kernel. So process management, memory management, I/O management, interrupt management, time management, and so on. That depends on the application or operating system. The services will vary. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.